Hi everyone, this is a short video. I hope it's going to be a short video for lesson 2. We're going to review some concepts and cover some new concepts. Lesson 2 starts today, goes until next Wednesday, and then we'll have a couple turn-ins that you need to do. But a lot of it is just reading and comprehending this week. We're still in that kind of period of the course where we're trying to make sure everybody is up to speed and everybody knows the same things about computers and about the web and about web design. You may notice me talking a little bit quickly today. That's because it took me about 2 hours to get through, and I definitely don't want to take anywhere near that long. This is only going to be a highlight of this material. You need to go back in and review the PowerPoints yourself, review your reading materials yourself. So, the slides that I'm going to be going over today are going to be in Blackboard. They're going to be right here in your lesson objectives. For lesson 2, and it is this one right here. As you can see, we're going to talk about search engines, a little bit about Boolean logic, and about academic concepts and fair use. So let's get started. So digital files, searches, and fair use. We're going to talk about some digital concepts because in order to understand how computers work, it's important to realize that what computers are just something that can store data very, very well and can do calculations based on the data that it stores. Almost everything else that a computer does really falls out of the idea it can store data and it can do calculations on that data, and then we can make something happen with that. In order to learn about that in the future, we're trying to get you some basic concepts and learn some of the jargon so you know exactly what your professors are saying in the future and what they mean by what they say. Then we're going to talk a little bit about search engines, and the reason we're going to talk about search engines is both because they're a website that has a database that has some programming in it, so it hits all of our course instructions as kind of a practical example, but it also introduces the idea of Boolean logic in a way that we can kind of test out and make accessible that you'll use in the future in programming aspects of courses. So then we got to talk about academic integrity, and tied into academic integrity is the idea of fair use. So how do computers store data? We're going to talk about data representation basics, talk a little bit about representing numbers, a little bit about representing text, and then talk about some file types. And mostly we're going to talk about the idea of file types. And you can come back into this PowerPoint presentation if you want to actually learn about different types of files. So what's the difference between data and information? Data is a value. Data means something, but it doesn't have any meaning attached to it. So if I just tell you 42, it doesn't mean anything because you don't know 42 what. 42 could be the name of a street, it could be a number, it could be a color that it's supposed to represent. If you don't have some kind of information attached to your data, then it doesn't have any meaning. So computers are really good at storing data, and the way they do that is by digitizing it into binary digits, ones and zeros. We're all very, very familiar with ones and zeros. We can collect those ones and zeros into files. And the way we should imagine our files is kind of a filing cabinet idea. We start at the hard drive or CD-ROM, the root directory. We typically give that a letter name. So we start with the C drive, and then we have slashes, and each of those slashes represents a folder that's inside of another folder, and we can just stack these folders up and organize our files. File organization and being able to find files on your hard drive is kind of an important concept. So if you are not really comfortable with that, make sure you review Unit 0, which has some discussion in there about that. Numeric data. If we're going to use a binary number system, we only have 2 digits, ones and zeros. So just like base 10, you can count from 0 to 9. And when you get to 10, you wrap around into the tens place. With binary numbers, you have from 0 to 1, and then we have the 2's place, and then we have the 4's place, and then we have the 8's place. And we can stack up our numbers to represent our binary digits. You don't have to memorize the associated binary, but you should be able to kind of figure it out and say, okay, this is the zeros place. So if I have a 0 in the zeros place, that's a 0. If I have a 1 in the twos place and a 0 in the zeros place, that's a 2. A 1 and a 1 is a 3, and so on and so forth. It just keeps adding up, and you can add them up together. That's how we do numbers, just straight representation. Characters are anything that is a symbolic representation. We can think of letters, we can think of math symbols, all these individual drawn things that we add up into words is what we call character data. Character data even includes emojis and things like that. This is what we call text in the short form. We say, okay, these are text. And so when we talk about text, we're talking about characters. It's important to remember that the character 1 is not the same as the number 1. 1 is the number 1 is a piece of data that doesn't have any real meaning associated it, whereas the character 1 is a text description of a 1. Those kind of differences will start to actually make impact as we get into future courses. For right now, just remember, if it's in quotations, we think of it as being text or characters. In order to use binary to represent characters, we have to have a coding table that we say, okay, this is going to be character data, and now we look up the numbers that are in this table, or in our data in this table, so that we can find out what letter it represents. One of the major ways of encoding data is ASCII, and that A, since it stands for American, should give you a hint that ASCII is only English letters and English characters. So ASCII for A is 1000001. B is 1000010. Each one just goes up by 1. C is one more than that. D is one more than that. And you add up all this table. Remember, capital A is different than lowercase a because it's a different visual representation of data. Unicode is the international format that kind of replace ASCII. It actually overlaps ASCII, so when you look up a number that's English, you can get the same number in Unicode and in ASCII. What we're going to deal a lot with in this class is UTF-8. UTF-8 is a lot of what a lot of English language web pages use. It's a variable length coding scheme, which means not all letters are the same size, but it uses 8 bits for regular ASCII letters, but can use more for other languages as it's necessary. So that allows you to kind of compress the size of your files and still have the accessibility that comes from being able to insert foreign characters if you need to. If you want to know more about that, there's plenty more in your book. So these, if we have ASCII text, we place it in a text document, typically, something like that. And we can tell it's a text document because it has the file extension .txt. Almost all files, they have a dot, they end in a dot, and they end with an extension. If they don't have anything there, it can be .nothing, which is technically its own extension. But typically, it has an extension that tells you what kind of file it is. You may have noticed on recent computers, a lot of computers turn off by default extensions. So if I come in here and I say new text document, it just says new text document. But this file name is actually new text document.txt. It's new text document. And that's why you can see the text document icon next to it. And in the type, it says text document. It knows because there's an invisible .txt. You almost definitely want to, and probably for the rest of your life and the rest of, at least the rest of your programming classes, come into your view options, and Mac it's in a slightly different place. I'm sorry, I don't have an example to show you. And find where you can show your file extensions and uncheck that. The problem is, in this course, a lot of times we'll start with a blank file. And so if we don't have our file extensions enabled, we have this text document, and then we'll come in here and we'll rename it .html. It's still a text file. It doesn't say it's an HTML. It doesn't show you an icon for your web browser because it still adds that hidden .text on it. If you want to actually make it an HTML file, you have to remove that .text, and it'll say, oh, you may have heard my computer chime. It says the file name might become unstable. Are you sure you want to change it? And I say yes, and then all of a sudden it gets loaded up. If it's saved as an HTML.txt file, it's still a text file, and it still won't be loaded by the browser. It's important to remember those distinctions. At least one person is going to turn in a file that way, and they're going to be very surprised when I send it back to them and say, this is not actually an HTML file. It may have HTML in it, but it won't load and display properly. So then we're going to jump past other different file types and little knowledge check that you can use. We jump into digital file types, which I don't feel the need to read to you, but I do want to talk about bitmaps versus vector graphics. This comes up in the web. We use different types of graphics for different purposes. So a bitmap graphic, excuse me, makes a table of all the pixels in a file, and it stores the color for each of it. That's bitmaps, obviously. JPEGs, GIFs, and files like that. This is how they work. When you zoom way in, you can see the pixels. A vector graphic uses math to generate graphics. So it says, I have a circle from here to here. I have a circle of a radius of this. I have an arc that follows these coordinates. I've got a line from here to here, stuff like that. Because it's math-based, when you zoom in or zoom out, it can recalculate what the shape is supposed to look like. So it enables sizing, or what we call scaling, to happen very, very easily. So they resize better. They're usually smaller storage space because instead of storing each pixel, you store these math concepts that draw it. A lot of times vector graphics are not as realistic as bitmapped images because we're going for simpler shapes. You can save bitmapped images as vector graphics, but you tend to lose a lot of the advantages of that. And you can literally edit a vector graphic in a text editor. You can actually describe a vector graphic as text because it's just instructions for drawing that graphic. One of the types of files that is a bitmap that you should know about, a bitmap graphic, is .png. What .png does is it allows you to set a transparent area. And that's very handy in the web. You want to be able to say, hey, this is my headshot. All this white behind me is actually transparent. And then you have a nice cutout of your head as opposed to having, you know, a white square with a head floating in it. If you want to layer graphics up, you can use .pngs for that. So that's super handy. So search engine basics. This is another one of those things where you just need to read it. It's not that long of a read. It's got a lot of extra information in there. Most of you have a rough idea of how it already works. But what we want to point out is that these search engines, the search terms that you use in a search engine, don't need to be sentences. Google is searching for keywords. So when you say something like, how much is a hot dog? And you ask Google, how much is a hot dog? It's the same as saying hot dog price. And Google will tell you prices for hot dogs. You don't need to say, how much air should I put in my tires? You can just say air tire pressure recommended and simplify your terms. What Google is doing is putting a secret Boolean search, a Boolean operator in between your terms. So what is a Boolean operator? Boolean means it can be resolved to either true or false. So Boolean conditions are conditions that you can say this part is true, and then you can say and, or not. Google search terms all have invisible ands between them. Copper, in this example, copper and harbor and mountain and bike and trails. Your Google search needs to have all of those words in it. With Google's advanced search, you can put ors in it instead. I would like to look for bike trails or running paths or deserted roads. It doesn't need to have all three of those. It just needs to have one of those. How a search engine works. It has a web crawler that reads every web page that is indexed by it. It reads the content, busts out the keywords, gives all the keywords to an indexer. Then it goes through and it clicks on all the links on your website and it goes to the destination of your link. Then it reads that page and analyzes all its keywords and gives it to the indexer. Then it follows all the links and so on and so forth. The indexer gathers up the URLs, all the addresses, all the keywords, and stores them into a database. The database stores all those keyword information, and then the query processor gives you access to that database by looking up the keywords that you give it and telling you what's the most likely correct answer. Obviously, Google has a bunch of other content in there we'll talk about when we get to search engine optimizing. But for the most part, this is the kind of the general idea. You just look at the words on the web page and then you store them in a database and search through them. I'm going to flip through some slides here. You can go back and read it. Talks about how this works, but basically it's so fast because it's all done in advance. And then finally we're going to get to our formulating searches page with operators. And basically this is going to walk us through and remind us how Boolean logic works. It's our introduction to Boolean logic. This is also these types of things will also be true when we're using our own SQL later, although we're going to do very minimal things. But when you hear about how SQL works, remember you can do ands and ors and nots. So how do they work? How do Boolean operators work? If you have and, both sides need to be true, and then it's true. True and true is true. True and false is false. If you have or, only one side needs to be true. True or false is true. False or true is true. False or false is false. True or false, true or true is true. And if you have not, it's the opposite of whatever it is. They're pretty simple concepts, but setting up our conditions and learning about how Boolean logic sets up conditions is a really critical concept in programming. So we're bringing it up here and we're going to let you use search engines to kind of get the idea of how it works. Now, Google used to let you put an or right into the search bar, but it's less good about that now, and it doesn't really seem to work anymore. Google kind of changes up some of their operators all the time. What you can do is open the advanced search in Google, and you can see that you can do all of these words and this exact phrase, which is the same as putting it in quotation marks, where it says, it has to say, in this one, provisionally named. It's got to have that exact phrase, provisionally named. It can't say provisionally, temporarily named, or have any words in between here. It's got to be exactly this phrase. And then we have the or next. Any of these words. So it needs to have either symptoms or stem. And none of these words, or not. Time you might want to use not if you're looking for a specific search term and there are other common search terms that end up being more popular than your search term, and you're having trouble finding what you want, you can use not to get rid of the other terms. So you're writing a paper about Martin Luther, the priest in the, what was it, 1600s, and you can only find results about Martin Luther King, Martin Luther King Jr. So you can say Martin Luther, not King, and it won't give you any answers related to Martin Luther King Jr. So this is how we're gonna visualize this Boolean logic, and we're gonna practice this week doing some searches to practice. Trying not to say the same thing. To practice these techniques, because all we're trying to do is get this idea into your head, get you familiar with it, and because you'll be using it a lot in your program. Little blurb on search privacy, please be aware of this. And then we're going to get to using web-based materials and fair use. So what is fair use? Fair use is this idea that you can use other people's property without their permission in very limited conditions. You can normally use other people's property for academic purposes. It is very, very important to remember that for us, this is not true. We do not obey fair use in our classrooms at Wake Tech. Normally, if you wanted to review something, you're a movie critic, you can use a clip of their movie, even if they don't give you permission, to mock the movie or to compliment the movie. And that's important because if it's a terrible movie, you might not want to give anyone permission to point out how terrible it is. Despite of that, we've kind of agreed in this country that you have the right to use small clips of something in order to talk about it. So review, criticism. You can even use small clips of it in order to make fun of it, like parody. It's what Weird Al does. He takes songs, he rewrites them, and makes fun of them, and he can do that because that is fair use. The phrase that is used is the use must be transformative. However, this is a very loosely defined area of copyright law. It mostly falls out of court cases and isn't as well written down as you would want it to be. So what exactly is legal and not legal can sometimes be a tricky subject. So our book kind of implies, look, you can just grab text, you can grab an image, but in reality, you can't actually do that. And when it comes to us at Wake Tech, you definitely can't do that. You can, you're cheating if you give or receive any unauthorized information. You are cheating if you are working together when you haven't been given permission to work together by your instructor. You're even plagiarizing if you take your own ideas and turn them in for multiple courses without permission for doing that. They call it self-plagiarism right here. So if you want to know if you are allowed to reuse something that you've used in another course, you must ask your instructor, or it is self-plagiarism. And that brings us to our last topic. ChatGPT. For those of you that haven't heard of it, it is an AI chatbot program that can give realistic sounding answers to common questions. What it did is it read a bunch of books and literature and online articles and things like that. It calculated how words relate to each other and when words are often used near each other. And so then when you ask it questions, it uses that probability training data to give similar sounding answers to things it's already seen. That's why it's so important to remember I'm saying similar sounding and not correct, not right answers. It sounds right, but it isn't necessarily right. It doesn't know anything. It doesn't understand anything. All it knows is that other people using similar words have described something in a similar way. There are whole sections on Reddit where people just sit around and make fun of ChatGPT and show some of the bad answers that it gives. It can generate computer code. Computer code often compiles but isn't functional. It can write essays. It's currently very shallow, and the general consensus is it does about C-level work. So the temptation has always been to cheat using ChatGPT. The problem with ChatGPT is that it's not always right, aside from the fact you won't learn nothing, but it's not always right. And since it's not always right, you have to have enough knowledge to know whether the answer is right. And if you have that kind of knowledge, then you might as well write your answers yourself. So for example, it gives inaccurate math answers often. It'll use the wrong type of math often. It'll make up a sentence that sounds like other sentences, but it doesn't follow math theorem. It doesn't follow math rules. It has just read math papers and it knows the kind of words they use, and it's pretty good at putting them together in a convincing way. So if you try to use it to generate a computer program, a lot of times it looks right, but it basically just stubs out a computer program that gets to the hard part, and it'll have a comment in there that just says, this is the hard part, you need to fix this code, because it doesn't actually know how to do things if it hasn't explicitly read it before. The Atlantic says, first and foremost, ChatGPT lacks the ability to truly understand the complexity of human language and conversation. It is simply trained to generate words based on a given input, but doesn't have the ability to truly comprehend the meaning behind those words. This means any responses it generates are likely to be shallow and lacking in depth and insight. In other words, it doesn't come up with anything new. It just paraphrases things that it's read before, and it may not even be right about how it does it. So one of the things we're going to be doing this semester is running our answers running our questions for all our discussion questions through ChatGPT and seeing what it comes up with. I'm not going to, if you want to read this, you can pause it. But this is the answer that it gave for our discussion question for this week. And if you look carefully, it gives a reasonable answer for what would be commercial copyright law, but it doesn't take into account the academic integrity agreement. So this answer, as good as it sounds, is actually totally wrong. It more or less implies that if a fellow student gives you permission to cheat off of them, well, then that's fine, because they're the copyright holder, so they can give it to you, and that would be okay to use. It implies that you can use anything under fair use. You could say, oh, well, I don't have copyright permission for this academic resource, but I'm going to use it because academically, like legally, I am not violating copyright. I am simply copying something for an academic purpose. That's not what our standard is at Wake Tech. So we have to make sure that you understand the difference between fair use and what our academic integrity agreement actually says, and understand that ChatGPT, as clever as it is, doesn't know everything. If you have any questions about these topics or this material, please do let me know, and I will answer them the best I can.